Hello friends, I am Dr. Karthik, Assistant Professor of Physics at the Majorwa College, Madurai. In my earlier videos, I have discussed about motion in a straight line, motion in a one dimension and motion in a plane, which are all the concepts of 11th standard physics. In continuation of all those videos, I am going to talk about friction in this video. What is meant by friction and what are all the concepts associated with friction. These are all the things which I am going to discuss in this video. Basically, friction is a kind of opposing force which comes into play when two bodies move over one another. In other words, when two bodies or two surfaces move one over another, or there is a relative motion between these two bodies or these two surfaces, the force which comes into play is called a frictional force. In otherwise, it is called the force of friction. For example, let us consider a block is placed here and I am applying a force F. This is called the applied force, the force which I am giving to move the block. Just because I have applied this force F, the force which comes into picture is called the frictional force. This force actually opposes the applied force and prevents the body from moving. As far as friction is concerned, there are two types of friction, two main types of friction. They are called static friction and kinetic friction. As far as static friction is concerned, when you apply force on a body, if the body still continues to be in rest, then the static friction has come into play. Just imagine this scenario. When a bus breaks down in the middle of a road and many people start pushing the bus in order to move it again. For plenty of time, these people struggle to get the bus moving. This means the static friction prevents the bus from moving forward. So that is called the static friction. This force actually comes into play when you apply a force on the body. So when the bus stops in the middle of the road, people start struggling to push the bus, but still the bus keeps in its rest position. Still the bus remains in its rest position. Then the force which prevents the bus from moving is called the static frictional force. Then what happens? People start pushing the bus harder and harder. At that time, at one point of time, the bus starts moving. Just at that point of time, the friction, or otherwise the static friction, has reached a maximum value called maximum static friction, or the limiting value of static friction. At this point, the applied force overcomes this force of static friction and then the bus starts moving. Even though the bus has started moving, you need to just keep on giving the force in order to keep the bus in a moving condition. Otherwise, the bus slowly decelerates and it finally comes to rest. That means you have to apply some sort of force in one form or the another. If you want to push the bus with just your hands, this is also a force. Or else if you start the engine of the bus and you give the acceleration, that acceleration or the force which you apply, that only keeps the bus moving. Otherwise, the bus decelerates at some point of time and finally it comes to rest over a period of time. So the static friction, it becomes maximum when you increase the applied force, and at that particular point of time when the bus starts moving, the applied force is more than the limiting value of static friction. So the other type of friction is called kinetic friction. What is meant by kinetic friction? This is the kinetic friction is the type of force which comes into picture when the bus has started moving, but still the frictional force exists between the tires and the surface on which the bus is moving. This type of frictional force is called kinetic friction. So this friction comes into play when there is a relative motion between the body and the surface. This static friction comes into play when the body still remains in its rest position and you keep on applying force to the body. So these are the major difference between static and kinetic friction. Now I am going to explain about the coefficient of static friction. What is meant by coefficient of static friction? As I have told earlier, the maximum value of static friction is denoted by this symbol. So what are the factors on which this maximum value of static friction depends? Look at this picture. Here I have applied a force here, but the body still remains in rest position. So the static friction has come into picture. The weight of the body actually acts downwards. According to Newton's third law, every action has an equal and opposite reaction. Since the body is in rest position and the weight of the body acts downwards, an equal and opposite force called normal reaction force actually acts in the upward direction. That force is called R, and that force is denoted by the letter R. This is called the normal reaction force R, and the limiting value of static friction Fs max is directly proportional to R. I am repeating it once again. The maximum value of static friction is directly proportional to the normal reaction force acting on the block. Here the weight of the block is acting downwards and the normal reaction force acts in the upward direction. The maximum value of static friction is directly proportional to the normal reaction force. So I have to remove this proportionality and I am putting a constant here. This constant is called the coefficient of static friction. In general, the coefficient of static friction is denoted by the letter mu. Here we are discussing about the static friction only. So I have given the subscript S here. So how to calculate the coefficient of static friction? Mu S is equal to Fs max divided by R. So mu S is equal to Fs max divided by mg. What is mg? As we know very well, the normal reaction force is just a reaction to the weight of the block or weight of the body acting in the downward direction. The weight of the body is given by W equal to mg. So since reaction force is equal to the weight of the body, that is equal to mg, I have derived the formula for the coefficient of static friction, which is the ratio of the limiting value of static friction to the weight of the body, or the ratio of the limiting value of static friction to the normal reaction force acting on the body. Whenever you want to find out the coefficient of static friction in numerical problems, you need to apply this formula. So this formula applies only when the body continues to be in its rest position, even if you apply force. So you are applying the force, the body still remains in its rest position. That's why I have given the subscript S here, because we are dealing with only static friction here. The body still remains in its rest position. I am applying the force, and now I am calculating the coefficient of static friction. This coefficient of static friction gives you an idea about how rough the surface is, because different surfaces offer different types of frictional force to the motion of the body. So this coefficient of static friction gives you an idea about the type of frictional or the kind of frictional force the body offers to the motion of the surface offers to the motion of the body. Now I am going to explain you about the angle of repose as far as friction is concerned. Consider this scenario. A block of mass m rests on this inclined plane. Alpha is the angle of inclination. The block has just started sliding down this inclined plane, and this is the limiting value of static frictional force Fs max. Since this is angle alpha, the weight of the block mg acts downwards in this direction. So since this angle is alpha, this angle is also alpha. Now I am resolving the weight of this block mg into two of its components, and this is mg cos alpha, this is mg sin alpha. The static frictional force Fs max is balanced by mg sin alpha, and the normal reaction force R is balanced by mg cos alpha. Now I am going to write down the equations as far as motion of this block on this inclined plane is concerned. Since the normal reaction force R is balanced by mg cos alpha, I am writing like this: R equal to mg cos alpha, and Fs max is balanced by mg sin alpha. So now I am going to combine these two equations like this: Fs max by R is equal to mg sin alpha by mg cos alpha. So this equation gets modified like this: Fs max by R is equal to tan alpha. We have already discussed earlier that I have told you that this Fs max is directly proportional to the normal reaction force R. So Fs max is equal to mu s into R. That means Fs max divided by R is equal to mu s. So Fx max divided by R is equal to mu s. So on comparing these two equations, I can calculate the coefficient of static friction, which is actually equal to the tangent of this angle of this inclined plane. This alpha is actually called the angle of repose. It is defined as the minimum angle of inclination of this inclined plane at which the block of mass m starts sliding down the inclined plane. So actually alpha is actually called the angle of inclination of this inclined plane. At this angle only the block has started sliding down this inclined plane. That's why this angle alpha is called the angle of repose. Now we have derived the equation that the coefficient of static friction is actually equal to the tangent of the angle of repose. You can use these equations in numerical problems related to friction in your NEET or JIPMER exams, etc. etc. So in this video, actually I have started discussing about the friction. What is meant by friction? It is actually the force that comes into play when there is a relative motion between two bodies or a body and a surface. There are two major types of friction, that is static friction and kinetic friction. As far as static friction is concerned, you are applying a force on a body, but the body still remains in its rest position. The type of force which comes into picture in this scenario, that is the body is still in rest position and you are applying the force. At that time, the frictional force which comes into picture is called the static friction. When the body starts moving, there is still a frictional force existing in that scenario, that is called the kinetic friction. When you apply more force on a body which is still at rest, at some point of time, the applied force overcomes the static frictional force and the body just starts moving. At that point of time, the static frictional force usually reaches the limiting value, that is called the limiting value of static friction. Then I have demonstrated how to calculate the coefficient of static friction. The coefficient of static friction is actually equal to the ratio of the static frictional force and the normal reaction force. The normal reaction force is actually equal to the weight of the body. It is just a reaction force to the force of the weight of the body which is acting downwards. So then I have discussed about the angle of repose. So I have derived the formula for coefficient of static friction in relation to the angle of repose. And finally I have given you relation between the normal reaction force and the static frictional force and the coefficient of static friction. Actually mu s equal to tan alpha is an important formula. Using this formula or equation you can calculate the angle of repose in any problems related to friction. If you like this video, please like the video. If you have any doubts or if you want to tell your feedback, you can comment on this video. If you have still not subscribed to this channel, please hit the subscribe button. If you want videos, if you want notification regarding the new videos, you can tap the bell icon adjacent to the subscribe button. Thank you very much.